Hello all, today in this video I'm going to provide a demo for heart disease detection with Naive Bayes with the same dataset. Already we have worked with different algorithms. Here we are going to work with the different Naive Bayes algorithm and make a comparison that which Naive Bayes algorithm is providing the better result. This heart disease dataset we downloaded from Kaggle. You can just give like heart disease prediction data set means you will just get the CSV file. So first we are just importing the libraries which we are needed and then calling our data set. Our data set is having this much entries, that is nearly it is having 1025 rows and 14 columns. Then we are getting the info of the data set when comparing while seeing the old peak value, that is only the only float value. All others you can notice it is integer. Here from this data set we are taking the target variable as the y variable and all others we will be taking as the x variable. So we are getting the info of the data set. Already we know that we saw that only one value, that is old peak is float and every others are integers. So that is displayed by getting the info of the data set. Then we are having whether this data set is having any null values. No, it is not having null values. Then we are getting the shape of the data set. Then we are plotting a graph by using the target variable, how many zeros count and how many one count is having in the target variable, and we are making a plot regarding that thing. Then we are moving to train test split. For that we are first determining the x variable. Within the x variable we are just dropping the target variable because all other variables than target we will be using for x variable. So we are dropping the target variable and every others apart from target will be taken as the x variable. Then for the y variable only the target variable is chosen. Then we are declaring other variables like x train, x test, y train and y test by the use of the train test split function and the x variable and y variable. And also we are declaring the test size as 0.2, that is 20% will be used for testing and the remaining 80% will be used for training. In this work we are working with multinomial naive Bayes. For that we are just importing the library which is needed for that. Then we are calling that library within a variable. That variable we are using for training the function by using the fit function and the variables like x train and y train. Then we are declaring the testing. For that we are using the predict function and the testing variables. Then we are plotting the confusion matrix plot by using the test variable and also the prediction which we have declared, that is the testing function which we testing variable which we have declared. By that we are just producing a heat map with the x variable as predicted values, y variable as actual values, and the title we are giving as a confusion matrix. Here you can notice we are getting only less number of variables. This is because we are using only 20% of the data. Remaining 80% we will be using for training only, and this plot is plotted by using the testing variables only. So only this. So if you want some higher count means you can just increase the testing percentage, or else you can just work with the train function also. That will be serve as the training confusion matrix. So but this is the testing confusion matrix. Then we are declaring the classification report by which we are getting the variables classification report parameters such as precision, recall, F1 score, support, accuracy, macro average and weighted average. For this heart disease data set we have got an 77% accuracy, and for every macro average like precision, recall, F1 score also we are getting 77 only. So in the next video we will be working with some other naive Bayes algorithm and we will make a comparison like which naive Bayes algorithm is providing the better results, or else mostly the three are same. So, if you are interested in knowing some other demo video means, please let us know in the comment box. Thank you.